All right, welcome back, guys. So far, we have looked at some guided medium. So we looked at twisted pair cable, coaxial cable, and fiber optic cable. Now, we will be looking at some unguided medium. So, unguided media are basically um, a form of medium that transport the electromagnetic waves without using a physical conductor. So previously, we were looking at technologies that were wired, right? But unguided medium are mediums that are not wired. So they are also referred to as wireless communication. So signals in wireless communication is Signals in a wireless communication, it's basically broadcast through free space, the region surrounding you, and it is available to anyone who has the device of receiving them. So, for example, suppose you own a radio, right? So the radio station will be broadcasting the radio signals at a particular frequency, and any radio device that has the capacity to accept or receive these radio signals can listen to what they're basically transmitting, right? So if you have a radio device, you can definitely pick up those radio signals and listen to the radio, right? So that is a type of wireless communication. Now we'll be looking into three different types of um, signals that are used in wireless communication. So one of them is radio wave, another one is microwave, and infrared. Now we already went over these three very briefly in class, so let's look at a little bit into the details. All right. So normally when it comes to wireless communication, in the electromagnetic spectrum, frequencies ranging from 3 kilohertz to 900 terahertz is basically used for wireless communication. All right. So normally radio waves frequency range from 3 kilohertz to 1 gigahertz. And then from 1 gigahertz to 300 gigahertz, that's the range for microwaves. And then from 300 to 400 terahertz, that's the range for infrared. All right, so these are some of the ranges of frequencies that are used for wireless communication. Now, for propagating these signals, normally three different types of propagation methods are used. So one of them is ground propagation, another one is sky propagation, and another one is line of sight propagation. All right, so in ground propagation, radio waves travel through the lowest point of the atmosphere, hugging the Earth. So these low frequency signals, they kind of go in all directions from the transmitting antenna and follow the curvature of the Earth. So you see over here, so suppose this thing, this one, hang on, let me point it out. So suppose this one is the antenna. Now this antenna will kind of transmit signal in all directions, and the signals will kind of hug the earth and then transmit throughout the curvature. All right, now the distance that a signal can actually traverse depends upon the power of the signal. The higher the power of the signal is, the more of the curvature that it can actually traverse. Right, so that was basically it for ground propagation. Now for sky propagation, what you have is normally in ground propagation, you would transmit radio signals of low frequency, but in sky propagation, you would be transmitting signals that have a bit higher frequency. All right, so Here, normally the signals are um, directed upward towards the ionosphere. Now, ionosphere is a layer in the atmosphere where all the particles exist in form of ions. Now, the radio waves, they radiate upward. Like, let's suppose this is the transmitting antenna. So it will be transmitting the radio wave upwards towards the ionosphere. Now, when it goes to ionosphere, it kind of reflects back to the Earth, and then any receiving antenna receives the signal. The advantage of using sky propagation is that it can traverse a longer distance. Normally, radio waves ranging from 2 to 30 megahertz frequency is propagated using this method of propagation. Now, the third method of propagation is line of sight propagation, and this is normally done for signals of much higher frequency. So frequencies above 30 megahertz are normally they normally propagate using this propagation method. Now, to use this propagation method, the sending antenna and the receiving antenna, they need to be faced towards each other. That means they need to be in each other's sight, thus the name line of sight propagation. So the sending antenna, it sends the signal, and the receiving antenna, see, they are faced towards each other. I'm just going to highlight this portion. The sending antenna over here and the receiving antenna over here, they're faced towards each other. So for this propagation method, they have to be in each other's line of sight, and this is done for extremely large frequency signals. All right, so the section of the electromagnetic spectrum, defined as radio waves and microwaves, they are divided in 8 bands. All right, so each of these bands are regulated by the government. So the very first band is made up of very low frequency bands, and this consists of frequencies ranging from 3 to 30 kilohertz, and these signals follow ground propagation method, and normally they're used in long range radio navigation. Now, low frequency bands, they normally consist of signals with frequencies from 30 to 300 kilohertz. They also follow ground propagation method, and they're normally used in radio beacons and navigational locators. All right. So the AM radios that we are very familiar with, that one belongs to middle frequency range, and the frequencies are from 300 to 300 kilohertz to 3 megahertz, and they follow sky propagation system. All right. Normally, cellular phones paging system, they use line of sight propagation, and they have they belong to the band ultra high frequency, and basically so on. All right, so in wireless communication, you basically have 3 different kinds of signals that we use, one of them being radio wave, another one being microwave, and another one being infrared.